Alright, so in this video, we're going to be breaking down the expression square root of the quantity a cubed times b to the fifth over c. And we preferably would want to use the same techniques that we've been doing in previous videos. So the idea, since we're dealing with the square root, would be to get this a, or the a cubed, into clusters of 2, so we can cancel the square root, and get this b to the fifth also in clusters of factors or pairs of 2. The c, we only have one of them, so we can't really do that with the c. We'll be stuck with a square root of c somewhere. So how does this actually work out? First thing I want to do is break down this a to the third, so I have clusters of 2. I'll also do this b to the fifth at the same time. So rewriting this gives me the square root of a squared times a. So I had 3 to begin with, now I still have 3. I have 2 here and I have 1 here. Times b squared times b squared times b. Okay? And then the c just gets carried along because we only have one of those. Can't really break that down any further. So in this case, I have all this stuff broken up. I have powers of 2, which is exactly what I want. And now I want to use the quotient rule and the product rule for radical expressions at the same time. You can do it in 2 separate steps, but I'm going to do it in one because you guys have seen like 1,000 examples at this point. So, at least hopefully. So I'm going to use the quotient rule and product rule simultaneously. This gives me square root of a squared, square root of a, times the square root of b squared, times the square root of b squared, times the square root of b, all over the square root of c. Okay? So basically, I took the radical, and since all I have inside the radical was multiplication and division, the radical could be applied to every single factor and every single thing in the denominator. So, what does this give me? Well, I have a square root of a squared. Since a is a variable, and we don't know if it's positive or negative, we have to put absolute value bars on it. So we have absolute value of a. Well, we have a square root of a here. Can't break down that a anymore, so we're stuck with square root of a. B squared square rooted. We need an absolute value of b. B squared square rooted. We need another absolute value of b. And we have this last square root of b here on the end. And this is all over c. Don't forget to carry along the things you're not working with immediately. Okay? So, what do we do now? We have all these absolute values that we're taking here of this a and these 2 b's. It turns out when you have a product of absolute values, you can combine them into one absolute value. So how does this work out? This gives us absolute value of a times b in absolute value bars. So we're just multiplying here, so I can change the order up. It's okay. And similarly, I have a square root of a and a square root of b and a square root of c. So how does this going to work out? I'll just keep the square root of c for now on the denominator. I have square root of a, square root of b multiplied, so they absorb into one radical. You have the same power, so it becomes a power of the 2 things in the inside of each. This gives us square root of a times b. Okay, all I did was combine these 2 things into under one roof. Okay. Okay, so now basically by rules with fractions, we have this absolute value being multiplied to the square root of a times b. So this can be rewritten as absolute value of a times b. Well, let's combine the b's. This gives us b squared times the quantity square root of a b over square root of c. This is just properties of fractions that we're using here. So we have this thing in the denominator, and I have things being multiplied on top. So if this were like over 1, you just multiply straight across just using basic fraction rules. So this is what we end up with. Absolute value of a times b squared times the quantity square root of ab over square root of c. Okay? And final step, I can combine these radicals because I have a quotient with the same radical on top and bottom. So I can put those all under one roof as well. So I have absolute value of a times b squared times one giant root with an ab over c. So that's basically it. We cannot simplify this any further. We pulled out all possible powers of a, b, and c. So we're left with this kind of ugly square root here, and this absolute value of a times b squared. And that is the end of this example.